a block weighing 10 Newton travels down a smooth curved track AB joining to a rough horizontal surface. Okay, the rough surface has a friction coefficient 0.2 with block. If the block starts slipping on a track from 0.1 meter above the horizontal surface, how far will it move on the rough surface? So first we will see what is the rough surface and where it is starting from. So the block weighing 10 Newton smooth. So up to here it is smooth. Okay, up to here it is smooth, then it is rough. Means after going to horizontal, from horizontal where the point from horizontal where horizontal starts, that is rough. So this is smooth. Okay, so the rough surface is 0.2. So if the block starts slipping down the track 1 meter away, so how far will it move before on the rough surface? Okay, so what we can do is we can directly apply the suppose it stops after traveling at point C. Suppose it stops after traveling distance S. So we can directly apply the work energy principle from point A to point C, between point A to C. So what we can do is if we write delta U plus delta K equal to work done external. This is the basic principle. So what are the different forces acting? So the forces which are acting are normal, friction and gravity. Okay, so normal will not be able to do anywhere because the object is moving perpendicular to surface. So anywhere if you take, suppose at this point the normal is like this, displacement is perpendicular. If you consider here, the normal is like this, displacement is perpendicular. So at all places normal and displacement are perpendicular. Okay, so what we can write is normal work done will be 0. Then we will have work done by friction. Okay, so what is work done by friction? So friction can do work only after point B, because before B the surface is smooth. So after point B we need to write. So what we will write is after point B, suppose it travels distance S and friction is what? F. So we can write it as, this one we can write as mu into F with negative sign. Why negative? Because object moving forward, friction is backward. So now we can write delta U, the change in potential energy. So minus mg h, change in kinetic energy. So initially at rest and finally also at rest. At point C, if you see, initially at rest and finally again at rest. So we can see the whole thing together. So that will be 0. Okay, delta K is 0 and delta U is minus mgh. And then we have minus mu times friction. So friction is how much? Mu, sorry, displacement time friction, the work by displacement time friction. So friction value is mu mg into S. So this much we have to do. So minus minus cancelled. So S is G cancelled, M is also cancelled. So H by mu. Okay. So H is 1 meter divided by mu is how much? Mu is given 0.2. So we are going to get 5 meters. So this will be the displacement of the object before it stops. Okay. One more way we can do is if we know that if object slides on a smooth incline, another way we can do alternate method. Alternate method. We know that if an object slides on an incline for height change of 1 meter, then the velocity at point B, how much will be the velocity at point B? Will it be root 2 gh? Okay, so 2 into g is 10, h is 1 meter under root. So how much is this? Root 20. So this is the velocity of the object here. Okay, if velocity of the object here, then we can see from here to means how much distance it will travel before it stops. Okay, so now apply the same principle between B and C. Work energy relation between B and C. Between B and C. Okay, here the relation was between A and C. Work energy between A and C. Work energy between A and C. Okay, so this is between B and C. So if you write between B and C, so half m vc square, final velocity is 0, minus half m vb square equal to the work done is minus mu mgs. So if you solve it, we are going to get the same thing. If you solve it, the vc is 0 and minus minus cancelled. So s you will get as vb square by 2 mu g. Okay, so how much is vb square? Vb square is 2gh divided by 2 mu g. Okay, so g cancel, 2 cancel, so h by mu. So again we are going to get same thing. So these are the two alternate methods which we can use for finding the displacement of the object.